Building a circuit to change alternating current frequency requires specialized components and knowledge. Here's a simplified explanation of a potential circuit design. The necessary components include firstly a rectifier which converts alternating current to direct current, secondly an inverter which converts direct current to alternating current at a different frequency, thirdly a filter to remove any unwanted harmonics from the output, and fourthly a transformer, optional, to match the output voltage to the desired level. The process involves several steps. The first step is rectification. The incoming 120 volts alternating current voltage is first rectified using diodes to convert it into direct current. The second step is inversion. The rectified direct current voltage is then fed into an inverter circuit which switches the polarity of the direct current voltage at the desired frequency. This process generates an alternating current output. The third step is filtering. The inverter output may contain harmonics or noise, so a filter is added to remove these unwanted frequencies. The fourth step is transformation, which is optional. If the desired output voltage is different from 120 volts, a transformer can be used to step up or step down the voltage to the appropriate level. Building such a circuit requires expertise in power electronics and safety precautions. The design and component selection will depend on the specific requirements and parameters of your application, such as output frequency, power handling capacity, and efficiency. It's highly recommended to consult with a qualified electrician or engineer to ensure the circuit is designed and implemented safely and effectively. As an alternative option, consider a variable frequency transformer, abbreviated as VFT. A VFT is a commercial device that can be used to change the frequency of alternating current power. It may be a more practical and safer option than building your own circuit. When designing and building circuits, it is important to understand and apply Ohm's law. Ohm's law describes the relationship between voltage, current, and resistance in an electrical circuit. The formula for Ohm's law is voltage equals current times resistance, or volts equals amps times ohms. Understanding this relationship is crucial for calculating the appropriate values for resistors and other components in your circuit, ensuring it operates as intended and preventing damage. When working with electrical circuits, particularly those involving 120 volts alternating current, safety is paramount. Always take necessary precautions to avoid electric shock. This includes working in a dry environment, using insulated tools, and disconnecting the power source before making any changes to a circuit. It is also advisable to have a qualified electrician inspect your work to ensure it meets safety standards. Another critical aspect of circuit design is understanding power dissipation. Every component in a circuit, particularly resistors and transistors, has a maximum power rating. Exceeding this rating can cause the component to overheat and fail, potentially damaging the entire circuit. To calculate power dissipation, use the formula power equals voltage times current, or power equals amps times volts. Ensure that all components are adequately rated for the power they will dissipate in the circuit. When working with alternating current circuits, understanding the concept of impedance is important. Impedance is the total opposition to current flow in an alternating current circuit, including both resistance and reactance. Reactance is the opposition to current flow caused by inductors and capacitors. The impedance of a circuit affects the amount of current that will flow for a given voltage, so it is important to consider impedance when designing alternating current circuits. When selecting diodes for a rectifier circuit, consider the forward voltage drop and reverse recovery time. The forward voltage drop is the voltage required for the diode to conduct current in the forward direction. A lower forward voltage drop will result in less power dissipation in the diode. The reverse recovery time is the time it takes for the diode to stop conducting current in the reverse direction. A shorter reverse recovery time is important for high-frequency applications. When designing an inverter circuit, consider the switching frequency and duty cycle. The switching frequency is the rate at which the inverter switches the polarity of the direct current voltage. A higher switching frequency will result in a smoother alternating current output, but it will also increase switching losses. A duty cycle is the percentage of time that the inverter is in the on state. Adjusting the duty cycle can control the output voltage of the inverter. When designing a filter circuit, consider the cutoff frequency and attenuation. The cutoff frequency is the frequency at which the filter starts to attenuate the signal. The attenuation is the amount that the filter reduces the signal at a given frequency. Choose a cutoff frequency and attenuation that are appropriate for your application. When selecting a transformer, consider the voltage ratio, power rating, and isolation. The voltage ratio is the ratio of the input voltage to the output voltage. The power rating is the maximum power that the transformer can handle. The isolation is the electrical isolation between the input and output windings. Choose a transformer with a voltage ratio, power rating, and isolation that are appropriate for your application. When building a circuit, it is important to use a printed circuit board, abbreviated as PCB, or breadboard to connect the components. A printed circuit board is a board with conductive tracks that connect the components. A breadboard is a solderless prototyping board that allows you to easily connect and disconnect components. Using a printed circuit board or breadboard will make your circuit more reliable and easier to troubleshoot. When troubleshooting a circuit, it is important to use a multimeter to measure voltage, current, and resistance. A multimeter is a versatile tool that can be used to diagnose a wide range of problems. Use a multimeter to check for short circuits, open circuits, and incorrect component values. When working with alternating current circuits, it is important to understand the concept of root mean square, abbreviated as RMS, voltage and current. The root mean square voltage and current are the effective values of the voltage and current in an alternating current circuit. The root mean square voltage is equal to 0.707 times the peak voltage. The root mean square current is equal to 0.707 times the peak current. When designing a circuit to change alternating current frequency, it is important to consider the efficiency of the circuit. The efficiency of a circuit is the ratio of the output power to the input power. Choose components and design the circuit to maximize efficiency. When working with high voltages and currents, it is important to use appropriate safety devices such as fuses and circuit breakers. Fuses and circuit breakers are designed to protect the circuit from overcurrents. Choose fuses and circuit breakers with current ratings that are appropriate for the circuit. When designing a circuit to change alternating current frequency, it is important to consider the harmonic distortion of the output signal. Harmonic distortion is the presence of unwanted harmonics in the output signal. Minimize harmonic distortion by using appropriate filtering techniques. When building a circuit, it is important to follow good wiring practices. Use appropriate wire gauge and insulation. Keep wires short and neat. Avoid sharp bends in wires. When testing a circuit, it is important to use appropriate test equipment such as an oscilloscope and a spectrum analyzer. An oscilloscope can be used to visualize the voltage and current waveforms in the circuit. A spectrum analyzer can be used to measure the frequency content of the output signal. When designing a circuit to change alternating current frequency, it is important to consider the electromagnetic compatibility, abbreviated as EMC, of the circuit. Electromagnetic compatibility is the ability of the circuit to operate without causing interference to other electronic devices. Minimize electromagnetic interference by using appropriate shielding techniques. The National Electrical Code, abbreviated as NEC, provides guidelines for safe electrical installations. It is essential to adhere to the relevant National Electrical Code requirements when designing and building electrical circuits. For example, National Electrical Code Table 310.15b16 provides ampacity ratings for various conductors. Understanding power factor is crucial in alternating current circuits. Power factor is the ratio of real power to apparent power. It indicates how effectively electrical power is being used. A power factor of 1 means that all the power is being used effectively, while a power factor less than 1 indicates that some power is being wasted. Improving the power factor can reduce energy consumption and improve the efficiency of the electrical system. There are several types of filters commonly used in electronic circuits, including low-pass filters, high-pass filters, band-pass filters, and band-stop filters. A low-pass filter allows low-frequency signals to pass through while attenuating high-frequency signals. A high-pass filter allows high-frequency signals to pass through while attenuating low-frequency signals. A bandpass filter allows signals within a specific frequency range to pass through while attenuating signals outside that range. A bandstop filter attenuates signals within a specific frequency range while allowing signals outside that range to pass through. When selecting a filter for a particular application, it is important to consider the desired frequency response and attenuation characteristics. Voltage regulation is the process of maintaining a stable output voltage despite variations in the input voltage or load current. Voltage regulators are used in electronic circuits to provide a stable power supply for sensitive components. There are several types of voltage regulators, including linear regulators and switching regulators. Linear regulators are simple and inexpensive, but they are less efficient than switching regulators. Switching regulators are more complex and expensive, but they are more efficient and can handle a wider range of input voltages and load currents. When selecting a voltage regulator for a particular application, it is important to consider the desired output voltage, current rating, and efficiency. Current limiting is a technique used to protect electronic circuits from overcurrent conditions. Current limiting circuits limit the amount of current that can flow through a circuit, preventing damage to components. There are several ways to implement current limiting, including using resistors, fuses, and current limiting integrated circuits. It is important to choose a current limiting method that is appropriate for the application and that will protect the circuit from overcurrent conditions. Thermal management is the process of removing heat from electronic components to prevent them from overheating. Electronic components generate heat when they operate, and if this heat is not removed, the components can overheat and fail. There are several ways to manage heat in electronic circuits, including using heat sinks, fans, and thermal interface materials. It is important to consider thermal management when designing electronic circuits, especially those that operate at high power levels. Grounding is the process of connecting an electrical circuit to the earth. Grounding provides a path for fault currents to flow to ground, protecting people and equipment from electric shock. Grounding also helps to reduce electrical noise and interference. It is important to properly ground all electrical circuits to ensure safety and reliability. Shielding is the process of enclosing an electronic circuit in a conductive enclosure to prevent electromagnetic interference. Shielding can be used to protect the circuit from external noise sources, and it can also be used to prevent the circuit from radiating noise to other devices. There are several types of shielding materials, including metal enclosures, conductive paints, and shielded cables. It is important to choose a shielding material that is appropriate for the frequency range and noise levels of the application. Surge protection is the process of protecting electronic circuits from voltage surges. Voltage surges can be caused by lightning strikes, power line switching, and other events. Voltage surges can damage electronic components, so it is important to protect circuits from surges. There are several types of surge protection devices, including surge arresters, transient voltage suppression diodes, and metal oxide varistors. It is important to choose a surge protection device that is appropriate for the voltage levels and surge currents of the application. Overcurrent protection is the process of protecting electrical circuits from overcurrent conditions. Overcurrent conditions can be caused by short circuits, ground faults, and overloads. Overcurrent can damage electrical equipment and cause fires, so it is important to protect circuits from overcurrent. There are several types of overcurrent protection devices, including fuses and circuit breakers. It is important to choose an overcurrent protection device that is appropriate for the current levels and fault currents of the application. Isolation is the process of separating two electrical circuits to prevent electrical current from flowing between them. Isolation is used to protect people and equipment from electric shock, and it is also used to prevent electrical noise and interference from propagating between circuits. There are several types of isolation devices, including transformers, optocouplers, and isolation amplifiers. It is important to choose an isolation device that is appropriate for the voltage levels and isolation requirements of the application. Electrical safety is a critical consideration when working with electrical circuits. Always follow safe work practices to prevent electric shock and other injuries. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses. It also includes de-energizing circuits before working on them and using proper lockout-tagout procedures. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. Component selection is a critical step in the design of electronic circuits. Choose components that meet the performance requirements of the application and consider factors such as voltage rating, current rating, power dissipation, and temperature range. It is also important to choose components from reputable manufacturers to ensure quality and reliability. Datasheets provide detailed information about electronic components, including their electrical characteristics, mechanical dimensions, and operating conditions. Always consult the datasheet before using a component in a circuit to ensure that it is suitable for the application. Schematic diagrams are used to represent electronic circuits. A schematic diagram shows the components in the circuit and how they are connected together. It is important to be able to read and understand schematic diagrams in order to design and troubleshoot electronic circuits. Breadboarding is a prototyping technique used to build and test electronic circuits. A breadboard is a solderless prototyping board that allows you to easily connect and disconnect components. Breadboarding is a convenient way to experiment with different circuit designs before building a permanent circuit. Soldering is a technique used to permanently connect electronic components together. Soldering involves melting solder, a metal alloy, to create a conductive bond between the components. It is important to use proper soldering techniques to ensure a reliable connection. Troubleshooting is the process of identifying and resolving problems in electronic circuits. Troubleshooting involves using test equipment, such as multimeters and oscilloscopes, to diagnose the problem. It also involves using schematic diagrams and datasheets to understand the circuit and its components. Signal integrity is the quality of the electrical signals in an electronic circuit. Signal integrity can be affected by factors such as noise, distortion, and reflections. It is important to consider signal integrity when designing high-speed electronic circuits. Electromagnetic interference, abbreviated as EMI, is unwanted electrical noise that can interfere with the operation of electronic circuits. Electromagnetic interference can be caused by external sources, such as radio transmitters and electrical equipment. It can also be caused by internal sources, such as switching power supplies and digital circuits. It is important to minimize electromagnetic interference in electronic circuits to ensure reliable operation. Electrostatic discharge, abbreviated as ESD, is the sudden flow of electricity between two electrically charged objects. Electrostatic discharge can damage electronic components, so it is important to take precautions to prevent electrostatic discharge. This includes wearing an anti-static wrist strap and working on an anti-static mat. Printed circuit board, abbreviated as PCB, design is the process of designing the layout of an electronic circuit on a printed circuit board. Printed circuit board design involves selecting the appropriate components, routing the traces, and creating the Gerber files that are used to manufacture the board. Microcontrollers are small, single-chip computers that are used to control electronic devices. Microcontrollers can be programmed to perform a wide variety of tasks, such as controlling motors, reading sensors, and displaying information. Embedded systems are computer systems that are embedded within other devices. Embedded systems are used in a wide variety of applications, such as automobiles, appliances, and industrial equipment. Power electronics is a study and application of electronic circuits that are used to control and convert electrical power. Power electronics is used in a wide variety of applications, such as power supplies, motor drives, and renewable energy systems. Analog electronics is the study and application of electronic circuits that process analog signals. Analog signals are continuous signals that can take on any value within a given range. Analog electronics is used in a wide variety of applications, such as audio amplifiers, filters, and sensors. Digital electronics is the study and application of electronic circuits that process digital signals. Digital signals are discrete signals that can only take on a limited number of values. Digital electronics is used in a wide variety of applications, such as computers, mobile phones, and digital cameras. Electronics engineering is a broad field that encompasses the design, development, and manufacturing of electronic devices and systems. Electronics engineers work in a wide variety of industries such as aerospace, automotive, communications, and healthcare.